Okay, well, good evening, everybody. Happy New Year. Somehow I drew the short straw to be the first speaker in 2026. And the topic I talked about with a lot of people over the last year is local geology. And we've got new members, we've got lots of people who haven't been for a while, people who've come back and have forgotten what they did know. So it occurred to me that perhaps one of the best things to do would be to do a bit of a recap about Black Country Geology. And when I started to do that, I started to realise that a lot of the things we take for granted were hard won by hard work in the past. And it occurred to me that there's probably a very good story in just explaining where some of the key things came from that have led us to our current understanding of Black Country Geology. So where do you start? And once I started going down that particular rabbit hole, I realised there is an enormous story to tell. So the most observant of you will have read the first slide and realised that this is part one, because I physically could not squeeze in all of the stories about all of the amazing things that have been done or that have been discovered in the Black Country that have revolutionised geology or been part of that general process of discovery. So I thought, particularly for those of you who may not know this story, it might be good to go on that journey with the scientists, from when they knew nothing to how they slowly teased out that knowledge to understand the Earth as we think of it today. So, part one begins way back in the past. So, I'm sorry about the order of this. So, if we think about the first geological knowledge in the Black Country, it was all about getting minerals out of the ground. It was all about useful rocks. And the question is, what did we know? Was it all completely random? Did people just take a spade, dig a hole and hope there was something useful there? Or did they know the ground? And at what point do we know what they were up to? Because it's only been a few hundred years that anybody's written anything down about the scientific stuff. So I had to trawl through what we know. And what we know comes down to some Latin script. Back in the Dudley archives, buried in there, there is literally a Latin roll from the Halesowen Abbey that is essentially a list of complaints and resolutions that the monks had to deal with that were brought to them for justice. And back in 1281, there's a record of a widow who brings her two sons to see the friars to get justice because they failed to give her 2 cartloads of pit coal to see her through the winter. So what does that tell us about geology and what we knew about geology in that time? Well, it's quite a big one, that, because it tells us that not only did people know coal was in the ground and coal burned, it could be used as a fuel, but it also suggests 800 years ago that they were actively digging coal for the simple purpose of warming their homes during the winter. So there's quite a lot of knowledge about coal in the ground. If we then look forward to the evidence we've got of other mineral working, we jump quite a way forward to the medieval period, where we see limestone being worked, places like Castle Hill, Walsall, and it's being burned. We know that technology goes a bit further back, at least to the Romans, when they were burning lime to make lime mortar, hydraulic lime. But we've got the evidence on our hillsides today. There are lime pies at Wren's Nest, there are lime pies on Castle Hill. So we know that people were actively working the ground and knew where some minerals could be found. But they didn't write anything down, and they certainly didn't call it geology. So this is very practical, getting the good stuff out of the ground. When we come a bit further forward, we start to see the ground being worked in a slightly different way, and people digging down and going underground from the surface rather than from a hillside in. So in 1561, we know that there are records of ironstone and limestone being worked in Walsall, and we also know upon Cannock Chase, Bow Desert Park, there are very shallow coal pits. We know there are bell pits operating to get the shallow coals from the near surface. And when does that become a scientific study? When does science crystallise, and when do we start doing things systematically? Well, the earliest records we've really got in the UK date to the Royal Society. And if we look back to 1602 in the records, we can find a record that relates to a particular time. This is a time when Queen Elizabeth I is beginning to think about the need to use the traditional fuel, which is charcoal made by using or slow calcining timber from trees. Those are now needed to grow tall to make ships, because we're being battled by the Spanish Armada. So there's a royal request to the royal chemists to experiment with coal, to use that as an alternative fuel, and the industries it talks about are iron making and glass making. So there's beginning now to be a scientific body who is looking at the properties of a mineral from the ground for the service of the realm. They fail, and this is where the story turns more towards the Black Country and Black Country entrepreneurs. So in 1619, a patent is sent to the Tower of London for the effective making of iron using pit or sea coal. And it's filed by a chap called Dudley, of Dudley. And he is the 8th natural heir, you have to say that these days, of the Earl of Dudley and his mistress Elizabeth Tomlinson. He's a bright lad by all accounts, and he's been literally brought back from Oxford University by his dad to look into this problem. The royal chemists have failed to use coal to make good iron for the realm. The reason for that comes down to the actual coal itself. And the royal chemists did understand that the problem with coal was it didn't burn as hot as charcoal, and it didn't burn as pure, because it had things like sulphur in it, which meant that the iron that you made bonded with some of the sulphur compounds and became brittle. So it wasn't good enough. However, in the experimentation that went on in the early 1600s by Dudley, he added the magic ingredient, which was limestone. Now, we've told this story many times before. I'm sure you've heard me tell it before. But the furnace at which this was done was called Askew Bridge. It's Lower Gornal, Himley border. And I suspect that what actually happened was that they were mixing ironstone and coal in a furnace and trying to block up the vent with whatever rocks they could find, and some of that might have been limestone. And because of that, the limestone melted into the boiling mixture in the furnace. It captured the impurities, the calcium in the lime, in the calcium carbonate, captured the impurities and floated them out as a scum, and it lowered the melting temperature of the mixture so that the iron would melt and flow and be pure, as good as any other iron in the nation. So we know then that geology is beginning to have value, and it is beginning to be looked at scientifically rather than slightly metaphysically or just as the rocks we've got around us. So he sets up an actual ironworks in 1626 to mass produce this iron. So things are beginning to move, and people are really thinking about the value they can get from the ground. So if we move on a little, if it will. Yes. So that's going slightly deeper. Then we look at the book he produces in 1665. Now 1665 is at the end of the English Civil War. So you might think, well, if they put the patent and proved it was good iron made using pit coal in 1619, why didn't everybody start doing it? And the answer is the English Civil War broke out. Now there's a big story there. I'm not going to tell all of that tonight, or we really will need part 4 of this. So I just wanted to have a look more closely at the book that Dudley wrote. And Dudley wrote a book called Metallum Martis, where he explains his methods and he's pitching his ingenuity to the Crown. But what is really interesting is in that book there is this diagram. Now this diagram, genuinely, as far as I can tell, is the first true bit of geological science possibly in the world. That's a big claim, isn't it? Well, let me explain it a bit. So this diagram in Dud's book is a map. It's not just showing you a little bit of the local territory. He puts with it a key. So he's telling you that the 3 A's is north. So it's a true map. He's telling you that there are features on this map. Dudley Castle. So this is a map of Dudley Castle Hill. He's then saying there is an order in which you will find the mineral layers in the ground radiating out from the castle as the point of origin. These circles. And those circles are coded with a size of circle that relates to which mineral seam you will find if you go digging there. It's got a scale. So it's telling you the distance away from the castle you might work. This is the world's first true geological map. The first true underground prediction of where mineral seams will be found. It is literally 180 years ahead of William Smith and about 160 years ahead of William Smith, 180 years ahead of the British Geological Survey. So even in 1665, local people are studying geology in a systematic and groundbreaking way, pardon the pun. So, moving swiftly on, what happens next? Well, I think it's important that we think about the bigger aspects of what's going on around the Black Country and the other thinking that's emerging, because it's really important that as we begin to add our little bit into the stream of knowledge that's flowing, that there is a feedback mechanism where we can understand what we are finding. And the first real institution to do that is the Royal Society. So the Royal Chemists and the Royal Astronomers that are operating independently under the Crown coagulate, if I can use that word, into the Royal Society in 1660. So this is the first institution of scientifically thinking minds in the land. Now what's really interesting about this to me is that they did this to have a college for the promotion of physio-mathematical experimental learning. Science, in other words. Now King Charles II granted it its royal charter, so it becomes something the Crown is very interested in for the benefit of the nation. And the Royal Society of London is then pushed into improving natural knowledge. So you can see how this is going to become the realm of nature. The mathematics, physics and chemistry is going to be focused on nature, and to all intents and purposes those are the tools of geology. Okay, so we've now got a scientific establishment, but there's no such thing as a geologist at this moment in time. There's no such thing really as a scientist. And what are they interested in the realm of nature? And the answer is minerals. when we actually look at what they were up to in the early years of that society, we see that they focus on empirical observations of minerals primarily, but then people start showing them these curious figured stones, fossils. So they're a bit unaware as to what these things can be. They're a little afraid of what they might imply, because this is a very traditional landscape of belief where we have an explanation for how things come to be, and that is about 7 days of creation. So we've got to be careful here. And then when we come a bit further down, by 1686, that natural philosophy is beginning to expand out into general curiosity about the natural world. Because the Ashmolean Museum, Dr. Robert Plott is one of the scientists there, and he's actually employed to go and wander around finding interesting natural things and then write books about it. I'm doing him a great disservice in this. And so you see that he then starts writing books about the natural history. Now, natural history to me as a geologist is a really important phrase. It's an important phrase because most people don't understand what it means. So there are two words there, natural, which most people do understand. It's all the green stuff out there, the things that flap about and crawl around. And then history, but they forget that bit, don't they? Because natural history, the history of nature, is mainly geology. But it doesn't really get thought of in that way, does it? Okay, so what are they going to do with this natural history of Staffordshire? Well, here we are, the natural history of Staffordshire. That's how it was presented. So it's still very much within the context of the realm. It's about serving the country. Oop, that's Robert Plott. What a jolly chap he was. Okay, so what happens next? Well, next, we now know we've got layers, and we know the layers don't always sit straight. So what does all this mean? Well, actually, the person to work this out was a Catholic bishop, a chap called Nicholas Steno. And I should, at this point, apologise because I am going to paraphrase and miss out an awful lot of science discovery because I'm focusing on the bits that I think are probably most relevant to geology and the Black Country. So I apologise to Charles Darwin at this point. He's not going to get a mention. But what we are interested in is the rock layers. So Steno was a Catholic priest who got interested in the rocks around him. And he basically started to wonder about the way up of the rocks and what was... And he looked at rocks and he thought about it logically. And he came up with some laws. So this is all about the first real thinking about the laws that govern the putting down of rock layers. And he came up with 4 rules. The principle of superposition. Now, I know there are certain people in the audience who've trained geologically and know what this is. But in a nutshell, what he said, in a paraphrased way, is in any sequence of strata, any stratum is younger than the sequence of strata on which it rests. In other words, the one nearer the top is nearer to our time and it's younger. The one down below it had to be there first, so it's older. So it sounds like straightforward common sense, but nobody had ever written that down before. So this is setting out a generic way of looking at rocks wherever you've got rocks. And that applies to the Black Country. He also said, were they laid down on a slope? And he noticed some of these rocks were upside down. You know, that can't be right. It can't have been put down like that originally. So he came up with this idea that, well, all these rock layers must have been laid down flat originally, and something must have happened to them for them to be in a different orientation. So he said this. He said, I reckon all the strata are deposited horizontally, and then after that they get deformed into other attitudes. So we'd take that as fairly simple stuff, wouldn't we? That's the rules of geology. But nobody had said it before. He also said that strata, either perpendicular to the horizon, up at an angle, or inclined, were at one time actually down there, flat. So he's perceiving geological processes of immense energy that can twist and bend rock layers. Okay, where are we going with this? Right, two weird diagrams. His third law is called the principle of strata continuity. Right, what the heck does this mean? Well, what he said was material forming any stratum were continuous. The fact that sometimes there's a bit missing, it was there, it must have been there, and something's happened to it to get rid of it. Now we know that could be a geological fault which moves them so that that strata appears to run out or stop, or it could be a valley has worn away the middle bits, so you've got two edges on the valley sides. So he started looking at the landscape and thinking, well, that rock layer there should pop out over there, shouldn't it? So he started to predict a bit about the order of strata and how they might appear within the landscape. He actually said this, that material forming any stratum were continuous unless some other solid body stood in the way. Now the reason he said that is because he came across geological faults where one layer of rock ended against something different. And he made the presumption that that was always there and it just stopped forming at that point. But he did have that opportunity to link rock layers across the river valley. Okay, what about the principle of cross-cutting relationships? Geological maps and geochemistry, as Mark knows very well, are the things that bring terror to geology students because you have to start interpreting all the mess of all the twisted, bent and broken stuff underneath your feet and making sense of it in terms of a series of steps in the history of the landscape that caused it to be so bent and buckled. Now what Steno said was this. He said, things that cross-cut layers probably post-date them. Okay, what does that mean? Well, it means if I formed a layer of rocks and then it breaks and something cuts through it, that had to be there for this to come up through it. So you can work out simply by those cross-cutting relationships what happened first. And in a block diagram like this, we can see things coming, things being cut off, things moving. You can work out the order in which all those things happen simply by looking at what cuts across what. So Steno came up with some pretty fundamental observations about how to read the rocks. And that's going to feed its way back into the Black Country thinking. If a body or discontinuity cuts across a stratum, it must have formed after that layer. Right. Now, let's get back to the Black Country. There's another issue. There's another issue here. We're going to talk about it in a second with these two pictures, but we've got rock layers. We've got evidence of fossil figured stones, they were called at the time, that are indicating things lived and were buried in mud. That means the biblical flood. So all these rock layers actually must have formed at the same time. And the biblical flood is a process by which the entire earth is churned, which means the heavier stuff drops out quickly and the lighter stuff eventually settles on top. Right, geophysics. Using the density of things, we can work out if that's what happened, because the heavy stuff should be at the bottom and the light stuff should be on top. So, two people, these people. No, I've got that the wrong way around, I do apologise. These people. So, we've got lovely named people. We've got Mr. Fetty Place Bellers, who is very interested in testing these theories, testing these ideas. And look where he comes to test his ideas. A coal pit at the west end of Dudley, because he knows there's lots of layers in a coal pit, and he can measure the density of all the layers and see whether or not that idea is right. He got a friend of his, a Mr. Frederick Hawksby, to help him with assimilating in a laboratory the specific gravity or the density of each sample he took from that coal mine of a uniform size. So he could work out whether or not the light stuff was at the top and the less light stuff was underneath. However, what he found was, like we can see here in the rock face at salt wells, that what you do is you find clay, which is specific gravity 2.65. And then you've got coal, which is, depending on the coal, is about specific gravity 0.9. So the heavy stuff's on top of the light stuff. So they disproved the flood was the cause of sedimentary rock layers. And that when you went down a coal mine in Dudley, the density had a cyclicity about it. It repeated itself. So conditions were repeating themselves that were forming these rock layers. It wasn't a single event anyway. Okay, so that's 1710. And that is now saying, right, we've got some scientific principles by which we can test traditional held beliefs about the way the planet formed. And actually Dudley is a fantastic place to test these things out, because there's lots of holes in the ground and lots of rock layers we can play with. But we can't get very deep in the ground because there's a lot of water in the ground. Come in Dudley again. Because in 1712, and I'm sure most of you know this, but Thomas Newcomen steamed up for the first time a really powerful pumping engine to drain the mines. That in its own right transformed the entire world. That meant that every area of the world where they were trying to get minerals below the water table and they couldn't pump the water out fast enough with buckets, they could now install a steam engine and that would do it. So this was a really, really important invention, again in this area, that allowed people to go deeper into the earth and learn more things. Simply put, but quite a complex and technical advance. As I say, it was pivotal because it enhanced mining. It opened up areas that you couldn't get the minerals out of because they were wet. And of course steam power and steam ideas started to spread around the globe and got improved again a bit later on by a chap called James Watt, who was in Smethwick. So, by the 1700s, in our journey through geological discovery, we now know there is an order to the strata, but it's not based on settling out in a big flood. We're starting to see and collect different bits and pieces from different rock layers, and we're starting to see that some things are different. Some of these layers are different from others. And that brings us on to the next set of discoveries. Now, this is one of my favourite bits, because this takes us back to the Royal Society. I'm quite a fan of the Royal Society. And these are letters in the transactions. And this one in particular is 1750. I should say as well, at 1750 we know there's very large scale mineral working going on in the Black Country. We know that there is at least 10,000 ironworks in a 5-mile radius of Dudley Castle, and we know that to feed those ironworks you need a lot of coal, a lot of fire, a lot of specific clays for furnace bricks, you need ironstones, and you need limestone. So there's a hellish amount of digging of the ground going on. So it's unsurprising then that in 1750 the Reverend Charles Littleton concerns a nondescript petrified insect. He's found a fossil insect. The curious fossil I now have the honour of presenting to the Royal Society is rare as it is elegant. So what is it? Where is it from? I discovered a single specimen of it in the limestone pits of Dudley in Worcestershire. a full table of them in the same place, which are now submitted to this learned body to help us to understand what they are. Your most obedient servant. So what do they tell him? What are they going to tell him about this fossil? Well, this is the fossil. This is the actual drawing of it from 1750. I think we can all guess what that is, can't we? That's a Dudley bug. So, but it's a curious fossil and they don't know what it is. And I love this bit. So they start to talk about it here. And I'm not sure what it is. They found some of them in Coalbrookdale. But when it comes to it, they think, well, I think it's maybe some kind of crustacean. Well done. But look at the name they give it. Bug loafer. So it is the Dudley bug. The original name they try to give it is bug loafer curta, what's that say? Flagoso. So we've now got the Dudley bug pictured in a scientific publication. And they've started to get really curious on a very personal level about some of these individual figured stones, these fossils. What are we going to find next? Well, we've got to move on a bit because those figured stones, that story, is going to grow, but not in this century, because they're still mainly focused on minerals. And evidence of that is the William Smith end of things. So this is William Smith. Now we know about William Smith. Most people think of William Smith as the originator of geological maps. We now know that happened a long time before William Smith. But what he was the creator of the large-scale map of England and parts of Wales that showed us the entire picture, not just somebody focusing on their own patch. However, where did all this start? Well, it started with fossils. It started with William Smith, the young lad, being taken on as a surveyor and surveying people digging trenches. And in a nutshell, looking at rock layers here that were different to the rock layers over here, but were the same as the rock layers over there, and he was joining the dots. And but his main contribution is that he found that he could tell which rock layer was which rock layer by the fossils that were in it. So this is the start of telling the order of the strata, the stratigraphy, using the biology, biostratigraphy. He recognised that distinct types of layers were always found in the same kind of order. He found that they were always different to the ones above and below, so he's using lithostratigraphy, the rock characteristics, to say they were different. But this is the most important thing he did. He really liked fossils, and he started finding that these things were not just curious stones, they actually could tell you some really important stuff about where to find the valuable rocks that you can make a living with. 1792. But he takes a while, because in 1793 he actually gets a job with a colliery, and they want a canal, which gives him his perfect way of studying the rock layers, because they're going to dig a dirty great trench across Somerset where there's going to be lots of layers that he can study. And he observed a certain order. He observed the same cyclicity we'd seen in that pit in the west end of Dudley. The rock layers obeyed density order, but there was a distinctive order, and sometimes it repeated. And you could tell from the fossils within it where you were within all of those rock layers. So he went on to say, when you've got a big slice, and this is a lovely phrase, on a large scale, the ordinary appearance of supposed slices of bread and butter. He actually looked at a loaf flop over on his table, and he'd seen all the rock layers, and he thought, they look the same. These slices of bread look a lot like the rock layers. And he then believed if he went from the east to the west across the centre of England, he would actually see the entire story of the development of the earth, layer upon layer upon layer. He said, fossils have long been studied as great curiosities, collected with great pains, treasured with great care, and at a great expense. So he knows how people are very curious and love these things, and are admired with as much pleasure as a child's rattle. So I love that, our hobby horse. But then he goes on to say it's been done by thousands because it's pretty, without the least regard to the wonderful order and regularity with which nature has disposed these singular productions and assigned each to its peculiar stratum. Phenomenal piece of realization. That's going to shape all of our thought. Let's move to a very famous geologist and story. And this is now going up to Scotland. Now, we talked a lot about layers, we've talked a lot about figured stones, but we haven't talked much about time, have we? Because in the late 1700s, the Earth was 4,004 years old. That's as old as it could be, using the genealogy of families in the Bible. But now Hutton goes to places in Scotland like Sicker Point, and he sees rock layers that have been laid down flat, according to Steno, lifted up at some point, according to Steno, and then eroded flat so that the next layers can be laid on top much, much later. And he now knows from William Smith to look for fossils in this lot and look for fossils in that lot, and they're completely different. So they're completely different sets of conditions under which they were formed, separated by enormous lengths of time. So James Hutton writes this book, The Theory of the Earth. Now, there's a lot that's not going to be told in this story tonight, but he actually sees the mind seemed to glow giddy by looking so far into the abyss of time, with no vestige of a beginning and no prospect of an end. He's seen geological time go from thousands of years to infinity, and that these changes that we're seeing in the rocks are now not the result of a single event like a flood in a few weeks. We are talking eons. This is a tremendous step forward in geological thought. It also challenges that diluvianism. That was the phrase they used for the flood theory. Plutonism was propounded to say that everything on Earth was produced by volcanoes. So the truth is, as ever, somewhere in between the two. But because he was able to see in places like this that there's a creation, then there's a destruction, then there's a renewal, a redeposition. He saw this as a process that keeps going on, that the surface of the Earth is continually changing, continually breaking, continually being rebuilt. So he describes something we take for granted now, the rock cycle. And all these things are emerging and being communicated. And local workers here in the Black Country have started to think about this. But again, a lot of this is pure curiosity. It's interesting. So, well, let's have another look at our rock layers. What's in those? Now, I love the fact that this book by James Parkinson is referred to as Parkinson's Organic Remains. It sounds like what you'd find of Parkinson if you dug his grave up, doesn't it? But what Parkinson did in 1804 was start to accumulate together some of this really focused looks at different types of fossils and pull them all into a book to see what are these things telling us, vegetables and animals, in the antediluvian world. Okay, ante means post, after. Diluvial is the flood. So James Parkinson's not, he's a bit cautious. He's not going to challenge the idea of a great flood, a biblical flood. But he's saying what happened after it. So this is the rock layers that come after the flood. And he starts to look and combine, using William Smith's what's coming in different orders of these rocks, to start to build up a better picture, a more full picture of life as it changes through the rock layers. So Parkinson is doing a fairly systematic, what do we know so far? A bit like one of my year-end state of the arts at the museums. What do we know so far? So he did it in 3 volumes, and it took him 7 years to do. And it's considered by most geologists or geologists who study the history of their science as a really fundamental work, because it started to develop systematic paleontology. And it was really changing the idea of curious, pretty things into things noteworthy, yes, for identifying where you are in the rock layers, but also this is telling us something about life on Earth and how life changed and developed even after the flood. Okay, let's look further on. So, while this is going on, it's still pretty random. There's still individuals doing their own thing. They haven't really got a club. The Royal Society is very diverse. It's lots of, as you saw from that first slide, mathematicians, physicists, chemists. Those are the tools of the geologist who uses those techniques to apply to the story of the planet we live on. So in 1807, the Geological Society is founded. And it's founded on these principles, that they want to publish that mineral monograph. It's still about minerals. Still, the main focus is about economic minerals. But they know now that they're having to publish little papers in amongst all the other chemist papers and astronomy and everything else. And they actually want to talk to the wider interest group that's forming around the geology subject itself. So they want it recognised as an empirical science, as a science in its own right that uses the techniques of the other sciences. They recognise that there's a new language appearing. We're talking to each other about stratigraphy and volcanism and things like this. There's a new language. So there's only a few people who can talk in that language, who talk regularly about rocks and are not seen to be too weird. So they think we should have our own club. And so they decide to set one up. And of course, as is the case in that day, it's gentlemen scientists who have a dining club. So they decided to start it as an informal club and see what happens. And it quickly changed into something quite different. So let's move on from 1807 to 1815. William Smith is now well known. He's known to all of these people who are interested in the science of geology. And William Smith has taken it upon himself to go running around the country, looking at every rock layer he can find and collecting fossils and comparing them all to each other. And after many years of doing that, he builds a picture of where the rock layers of different ages with different fossils in stick out of the ground in the whole of our territory. His purpose is still, as it says here, so that the most proper soil will be known for where you can plant woodlands. It's the most proper soil for miners and colliers to find their wealth, in searching for metals, for stone, for builders, for brick earth, for making bricks, for the inhabitants of dry countries, for finding water. So Smith has seen the real worth of the science of geology to people. And he also goes on to say, if you think this is just an academic exercise, this is going to save you money. It will prevent you from expensive, wasteful trials in your mines. No point digging over there, minerals over here. He goes on to say, it will show you how far you can work, the perfection of the extent of these things. He literally mentions fuller's earth and sand for glass makers, stuff which is relevant to our area very much. So, by 1815, we now know a bit about the order of the rock layers. We've got principles for how they start flat and get bent. We know what kinds of stuff you can find in there, which are going to tell you something about life on Earth, but also which layer you're in. Where does this go next? We're building up a proper science now, aren't we? Well, it moves on to yet more systematic study of the fossils. So the first thing I'm going to refer to, and there's a lot of this, so I'm going to cut to the chase on just two different things. This is J.S. Miller. Now, Miller was a curator of geology, a kindred brother to me. He was based in Bristol Museum, and he was particularly interested in these sea lilies, because there's a bit of debate as to whether or not they were actually animals or plants. And he was the guy, really, who, looking at the systematic biology of these things, determined they were definitely animals related to starfish. So he's probably very significant for the first true fossil monograph, as far as I'm aware. But probably one that's more relevant to us here in the Black Country is this fella, Brongniart, a Frenchman. So Brongniart, obviously, and Cuvier, he was working with, were not happy that the Dudley bug should be called bug loafers. So they decided to do a more thorough and systematic study, and this is it. In his basic work, noms trilobites, those trilobites. So he talks about the petit calcaire, the small limestone fossils of Dudley, and he goes on to classify things, but he names the Dudley bug Calamine Blumenbach, after Blumenbach, a German paleontologist, who he's a big fan of. It's a bit like me finding a fossil and naming it after Brian Cox, because I think he's brilliant. So that's what happened with Dudley bug. He's named after a German geologist. But the reason they were looking at trilobites is because around about this time, they were struggling to divide up certain groups of rocks, in particular the stuff in Wales. And that becomes quite a heated debate later between scientists. But if you go across Wales, the oldest rocks, the deepest one down in the rock pile, we think of as the Cambrian now. Then you come up to a series of rocks called the Ordovician, and then you come up to the Silurian rocks, which pop up here, and Ordovician rocks down at Bark Green. Right, Cambrian rocks deeper down underneath us here. So this is relevant, but they're struggling to divide them up on the basis of seashells. So they need different fossil groups. So they start to look at trilobites, and trilobites are going to give them that means to divide up as a special group of animals that particular set of rocks. So you can see geology's moved on, hasn't it, from digging random holes looking for the coal to actually being able to use specific groups of animals to divide up specific sets of rocks. Precision is coming into our science, and we're only at 1822. So what happens when you've got that scientific knowledge? You've got a society that's pulling it all together. You've got lots of people talking about it. Well, you suddenly start to generate a bespoke science that is useful and that people want to study to become geologists. So this is the time that geologists really appear as independent professionals. So we start to see universities, Charles Lyell, writing general textbooks about geology in which he encapsulates the Steno principles, the William Smith principles, the generic stratigraphy, the paleontology, and he's writing an attempt to explain former changes on the Earth's surface by references to causes in operation. So So Lyell is becoming the first textbook writer, storybook writer for geology. Now, his principles of geology really revolutionised the spreading of the word of geology as a coherent, systematic study. He also popularised that idea of the way the world works today. If you see a volcano erupting producing lava, and you see a lava bed in the rock layers, it's probably formed by the same principle. So Charles Lyell in 1830 was the one who came up with the phrase, the present is the key to the past, this uniformitarianism. And he was very much a fan of the idea of very slow, gradual change. So we get in the popularisation of our science, and that is reaching into our area too. I just put this on as a footnote, really, but that was one of the most important textbooks for Darwin when he jumped on the Beagle, so that when he was turning up at all these new amazing lands, he got some guiding idea of how to read the rocks he was looking at. He was also a good geologist, to be fair to Darwin, but yes. Okay, what happened next? Well, the next thing is the Royal Society, the Geological Society, the Royal Astronomical Society, realised that actually it's all a bit central, and they want to start reaching out and getting more people engaged in science generally, and so they formed the British Association for the Advancement of Science. This is a really important organisation for our story. What's also very interesting to me, painfully so, is the 27th of September is my wedding anniversary, and it's also the anniversary of Wren's Nest National Nature Reserve, which means that every big anniversary I have to abandon my wife on our anniversary to attend to geological duties, which causes me lots of trouble. Okay, so the British Association for the Advancement of Science, and it really is, they can see science really beginning to become a powerful thing, a really useful thing, particularly as it's reaching out into the empire, and you need people out there where they're taking over and conquering places. Wrongs and rights not in this ethical discussions, I'm just talking science. So they realise how useful these skills are going to be, and they need more people to do it. So they want to give a stronger impulse to scientific inquiry. They want to push it out there, and they want to attract more national support for science. They want to have better communication between the different groups of scientists, because they realise that different groups of scientists are slowly but surely turning into different species, talking different language, and having strange behaviours that relate to their particular discipline. So they developed the British Association. What's really important to our story is that right from the outset they decided they were going to take science out to the regions. They weren't going to keep it all centralised in London. And our particular part of that story is that in 1839 they decided, because of Sir Roderick Murchison, who was publishing a book on geology that year, they'd come to Dudley. They'd come to Birmingham for the main meeting, they'd come to Dudley for the field trips. By doing that, they inspired the setting up of the first Dudley and Midland Geological Society and Field Club, which was the 7th oldest geological society in the world. You guys sitting here tonight are part of the 7th oldest geological society in the world, that was founded because a David Attenborough style character called Roderick Murchison came to Dudley in 1839. What did he do? What was all that about? Okay. So when he came, he was on a book tour. He was promoting his book. Now, there's a bigger story I'm not going to go too much into here, but basically Murchison wanted his studies of all the rocks from here to Wales to include a big chunk of layers that don't really belong to the Silurian. There was another chap called Adam Sedgwick who wanted, coming the other way, all the rock layers coming into the Silurian to be called the Cambrian, and they fell out. However, as ever, systematic science was the truth of it. Now, he defined, using Dudley fossils like this one, Trimeris, only found at Castle Hill in Dudley, to identify unique fossil assemblages, unique paleo environments that defined different times on Earth. Now, he did that very effectively and very systematically, but this is now not just doing the paleontology or not just doing the layers, he combined them both into a proper geological history, holistic evidence. And really strange and really sad, William Smith, who did that amazing geological journey across the entire UK to work out the entire order of all of the rock layers, died on his way here in 1839 to hear Murchison speak. He caught influenza and he died in Warwick on his way to see Murchison. So that's just a bit of irony I stuck in there for good measure. However, of course, it did give us our society. Now, for those of you that didn't make the 50th anniversary, I'm going to repeat a tiny little bit of what I said on that day. For those of you that did, consider it revision. So, what we know from the histories and from reading our own memoirs, we had the impetus from that 1839 visit by the British Association. So, Henry Beckett said a little while later, in a paper he wrote, that there were exhibited at Dudley for that meeting a number of Silurian and Carboniferous fossils which belonged to several inhabitants of the town of Dudley. Consequent on that exhibition, a permanent society was formed and a museum established. So that visit by that geologist put the first museum in Dudley. Now, we had Murchison himself to give us the first lecture. That would be like us getting David Attenborough. That's how much of a kind of scientific luminary Murchison was. So that was phenomenal. But for then to have him come and say these really famous words, boldly and truthfully about the quality of the rocks here. In no part of England are so many geological features brought together in a small compass than in the environs of Dudley. We've all heard those words. Or in which their characters have been more successfully developed by the labours of practical men. We've all heard those words, and that refers, oddly, from a gentleman scientist to the working classes. But then the bit that doesn't tend to get added to that is where else then can we find a site to store in which records of the past can be more successfully stored, where we can store up for instruction both the types of fossils and the evidences of the mighty operations that mark the more ancient conditions of the planet. He's saying you need a geology museum here because this is a special place. So he's saying that to this society. He's asking us to put a geological museum on the map. And they do. It's not quite the geological museum you might imagine, because the first one is actually in a pub in the town. It's called the Britannia Inn in Dudley on the marketplace. And because of the generous owner, Mr. Joss Bennett, basically he liked geology, he was really interested in this, so he decided he'd alter his building to build a museum inside the pub. And he would create some rooms where the Geological Society guys could meet and talk about these lovely fossils. And these are fossils from our collection, which were on display in that museum. The red number tells us from a catalogue in 1912, these were part of that original museum. We know the opening times were Monday to Saturday, 6 days a week, and we know that they were between the hours of 10 a.m. and 4 p.m. before the drinking got too serious and people might wander off with our fossils. But the interesting thing is that all of the great scientists came to see it. They came to have a good pint of ale, like tonight, to talk about rocks, like tonight. So we're still doing, and true to our mission from the 1840s. Professor Beckett says it nicely. He says, the fame of that noble museum extended wherever geology was held in repute. And it contained unrivaled treasures. And it still does. So, that was 1841, 42. A few years later, 7 years later, Murchison decides, I'm going to bring that lot back again. Now, the difference in that decade is phenomenal. Not just in growth of scientific knowledge, but look at what's happened. The first time he got the mine owners together, people who got a few fossils, and he put a nice display on. Look at it now. 10 years later, he takes them into Dark Cavern in Dudley Zoo. 15,000 people follow him in to listen to him. It's a stadium gig for geology. He's there in the middle with his speaking trumpet, because there's so many people. And the Earl of Dudley puts on a grand show. So that also brought 100 of the top earth scientists from the UK and a lot of dignitaries to come and really marvel at the spectacle of the geology of this area. It cemented Dudley's reputation as a world-class place, and it entered folklore. That illustration is from the Illustrated London News of 1849, and it triggered a whole cascade of new interest in geology. However, the geology was still mainly about the minerals. So I'm not saying it shouldn't be, I'm simply saying that the purpose was still about making money. So a few years later, 10 years later, exactly a decade later, another local geologist, J.B. Jukes, who went on to become a great geologist, wrote another book. And this time, he's summarising everything people were finding in coal mines. And this is a phenomenal piece of work. And just for your delectation, should you desire to later, I've got it here with me. So if you want to see what that book actually did go into, you can see the actual text of it here. This is the original. So I bought it for you to have a look at. So this is an amazing piece of work, because it's the first and earliest coal field. Loads of information, loads of mines. Up to 1,500 collieries operating that little piece of land in the heyday. So there's lots of information, more information probably than anywhere else at that time. Lots of things being found, lots of new fossils, and lots of interest with the local Geological Society. It did two things, this piece of work did. It changed a more simplistic view of what the ground was like, the geology was like, into, crikey, this place is complicated. A lot has gone on to the rock layers in this place, which is a big story. It also allowed some other questions to emerge. The coals and the limestone are dead easy to get at in this middle zone. But then on either side, there's great big piles of red sand and red claystone. And we can't, and the coal just runs out. It just hits a wall of that stuff. So what's going on? That's a really important work, because it's telling you a really phenomenal amount of detail about what's going on beneath the coal seams, in the coal mines. And it was fundamental from the way in which the British Geological Survey would move forward to do its coalfield memoirs. Again, Black Country leading the way. Right, let's move 3 years later to 1860 to 1862. And our society's gone through a bit of a change. So from 1842 to 1862, it had its meeting rooms in a pub in Dudley, and it had a museum in the pub in Dudley. And when we look at the reports from the committee and again, Julie, for you, I've brought in the proceedings from the Second Society and the proceedings from the First Society as a bit of what we want to tell everybody that we've been up to, set of newsletters, if you like. And what you can find in there are bits of information that tell us what was going on. And Hollier, who was a mayor of the town of Dudley, but he was also a member of the society and a committee member, has started to think this pub museum isn't good enough, because he's a bit disparaging about it. So when you read it, he notes that though still open, it's hidden in an old malt house. So hang on a sec, it's still open. It's not hidden then, is it? So there's a bit of language going on here. Now, whether that does reflect his desire as the mayor of the town to have a much better museum, or whether the actual pub is on its last legs as businesses do, we don't know. But he also states, this is Beckett now, states that perhaps the most important thing was not just the fossils, but it was the people. It was the stuff that the fieldwork did. And I do encourage you later, have a look at some of these notes and you'll see just how active those members were in getting out there, looking at things, finding things, writing up sections, conserving things. It's not an easy read because it's a different world, but it's very informative. Okay, so they decided anyway to move on and build a new museum, and they got that money together over the next 20 years and built the whole upper floor of a building called the Mechanics Institute on Wolverhampton Street. Became the new museum for the Geological Society, and they had a library which had those very books in it. So what's going on with those red rocks then? The coalfield has been explored, and now they've hit this problem where the red rocks are a bit featureless. There's not a lot going on, they're all red sand and there's no fossils. So we've got the next challenge of our local geology. There's structures, so we can see there are sand dunes in some of it. That's in Worsley, so that's Bridgenorth sandstone in Worsley, Permian. So we need to know a bit more about this. And actually, a bloke literally came to have a look. A chap called Edward Hull. And this is his memoir. If you want to have a look, if you're interested in red sandy bits, this is his memoir. So this is what he wrote about the red sandstones. And his work was important for another reason. All right, it's the first systematic description of these red beds, and they're not all the same. And he divided them up so you could see the differences. But probably, I don't know if this is true, but it's certainly the first one I'm aware of. So his work included in there a chapter about the Bunter sandstone. That was the old name for the Sherwood Sandstone Group. But he starts to look at that as a water resource, and he starts to see that as an important aquifer. Now, I don't know to an earlier reference in any memoir or any scientific text about the rocks as aquifers, as really important aquifers. They must have known it, but they didn't really talk about it. Let's have a closer look at some of these red rocks. So this is Barbeacon, and this is the lower layer of the beds, which has got angular pebbles in. This is called the Hopwas-Breccia. And sitting on top of it, we've got the Bunter pebble beds, which is now called the Kidderminster Formation. But why am I interested? Well, the reason I'm interested is because when they chase the coalfield sidewards, they always went smack into a vertical rock face of this stuff. And they didn't know what that meant. They were trying to work out how that could be, given that they've got these principles which say those layers should continue horizontally, but they keep coming up against these blocks. Well, they also got a bit of an imperative to sort this out, because the easy to get at coal is running out. the industries of the Black Country are running out of fuel. They've got to find more coal. They've got no choice. But because of Edward Hall, because of Henry Johnson, a local mine surveyor in Dudley, in Trindle Road in Dudley, they've started to look at these red rocks and they're thinking, hang on a sec, these red rocks over here seem to run down onto the top of the coal. So maybe this isn't a cliff, but maybe it's a break. And maybe the land's moved vertically. So I wonder if the coal's still down there, we just got to go a bit deeper for it. So they're desperate to find more coal. They guess the thick coal's there. But when they chase it, it keeps hitting that blooming wall of rock. So was it a sea cliff, this thing? Was it literally where the coal seams lapped against the sea cliff? Or does this represent the flood? Is this the washing out of the coal seams and the deposition of sand from a river? They don't know what's going on, but they need the coal. So, in 1870, Henry Johnson, local mine agent, is confident. He says, no, this geology stuff's good. We can predict things now. We know enough with this science now. I'm confident that if we dug a hole here, we'll go down about 500 yards and we'll find the coal. But it's going to cost us a fortune, because it's not going to be as easy as just digging a pit in your back garden and having it come straight out the ground. We've got to go through that red stuff. And so he persuades a lot of people to have a go. They invest. There's a big story there. We can tell that story another time. By 1874, they've dug a shaft and they've found a thin coal at 380 yards. And then they go on to find the thick coal at 418 yards. Yes. So they've found what they're after, and they've proved that that red rock was once on top of the rest of the coal field, but it's been washed away. And the sides have slipped downwards and preserved that red rock on top. In 1876, they've driven out roads into the thick coal underneath the red rock, and they've got at least 110 acres of thick coal proven. And they start to open up the mines. This is the Jubilee Colliery, which is in Sandwell Valley, where where the Nature Centre is now, where the RSB is head. Now, this piece of work, again in the Black Country, proved great earth movements are happening after the formation of some of these rock layers. It gives us a timing for certain periods, earth storms of intense earth movement, based on the rocks it's breaking and shifting. But more important to most of the people who'd invested, it gave them 90 years of ironworking that they wouldn't have had without it. So that little geological venture kept the Black Country going. Now, I'm going to come to something that's been close to this society's heart, thanks to a number of people on the front row here, for a few years now. And that's all very well about the ancient rocks, the hard rocks, but smeared across the top of the Black Country is this pebbly clay stuff, and that isn't solid. It's loose sands and gravels with big lumps in. So what's that about? There's one of the lumps from Rowley Regis, from the Birmingham Philosophical Transactions. So this is 1872. And there's a famous fellow called Reverend Henry Crosskey. And he decided, he just got into the glacial story. Because by now, people were looking at this stuff and were comparing it, particularly a chap called Louis Agassiz, was looking at the way in which ice in the mountains and ice sheets created layers of loose rocks that moved big stones about and left them where they shouldn't be. So he got really into this new science of glaciology, a sub-discipline. In particular, he was interested in the fact that lumps of rock could be matched by looking in detail at what they were and what their structure was and what the crystals were. You could work out where they'd come from. So if you got a big lump of this stuff, you could work out what it was, you could compare it to a mountain and say, blimey, that's come from over there. And you could work out then where the ice was bringing the stuff from. He carried out some really detailed field work, and he really helped to resolve another issue, which was about how these deposits formed. So it sounds daft, but we now take it for granted that ice sheets move out of the mountains, come together, form an ice sheet and plough across the landscape and then dump a lot of stuff they've scraped up wherever they melt. We believe it now, we see it. But back then, a lot of people hadn't seen those processes. The early rumblings of those processes were being discussed about, so people didn't know how these things got to where they got to. And one of the theories was that the entire UK got submerged with water, that the sea level rose, and that these things were on rafts of ice. And as the ice melted in the sea, it just dropped everything as a layer of pebbles and sand. This stuff suggested otherwise, because this is where solid rock has been scraped and marked by the passage of heavy stuff scraping across the top of it. Those are from Rowley. Now, if you want to see more of this, I would encourage you to do it. This is the Lapworth Museum. Has got his collection of the stones from those glacial deposits. They tell us a big story about the movement of the ice. Obviously, because ice is pretty powerful and it destroys things pretty effectively, it's the harder types of rock that we tend to get preserved. So, and it's some of those bigger blocks of those hard rock types that we can match back to the mountains from which they came. So this was all going on at the end of the 19th century. One of the phrases that I really love, and again, please, if you haven't done it, look at the Birmingham Erratics project. There is a phenomenal website with lots of lovely information. One of my favourite quotes from Lapworth ever is this one, when he's referring to Crosskey, and he says, Crosskey caught the infection of the true geological fever, a fever which leaves a patient but with death. In other words, once the Cupid's arrow of geology has struck you, you're in it for life. You're curious for life. Isn't that beautiful? Okay, coming towards the end now. So, where were those maps, and how did they get to working out the ice flow, where it went exactly? And of course, this is by the distribution of these boulders. Every dot on this map is a boulder that's sitting out there that's been dropped there by ice. And you'll see the shapes of those marks are different, referring to the different types of rock and where they came from. So I've narrowed that map down. This is by Martin, Fred Martin. He did this map as part of an exercise plotting glacial erratics in quite a big area of the central England and Wales. And he proved by distinguishing the types of these boulders that there were two distinctive movements of ice that are recorded in our area. So he was only an amateur geologist, so he's only like one of us. But then again, as we've seen so far, a lot of those big discoveries in our science didn't come from the great scientists, came from the practical people. So Martin was an amateur geologist. Why did he get into this? Well, he got into this because we're back to the British Association for the Advancement of Science. So they set up a glacial erratic committee, a committee to go and find these things and work out where they've come from and work out where they're now lying. So they systematically plotted the locations, and you'll see there are certain patterns in their distribution. So here roughly at Frankley Beaches, at Romsley, coming up through Hagley, round to Harborne and back to Rowley, there's a loop, a tongue. And where you get the end of a glacier, end of a snout, you get a terminal moraine, where a lot of stuff gets dropped in a more or less arc-shaped pattern as the ice melts and retreats and dumps stuff. Also, as the ice is advancing to a point where it can maintain, it's like a conveyor belt dropping stuff at the front of the glacier. So we've got patterns that can tell us a little bit about where things got to, where they ended up and what they were doing, but also the rock types too. So he was able to distinguish the stuff over there as coming from Scotland and the stuff over here is coming from Wales. So that story's been told before, but please do have a look at the Birmingham Boulders website. It's fantastic. Okay, so where does that leave us? Other than a sore bum from sitting there listening to me for too long. So where we are up to 19... Ooh, the other map didn't come up, did it? Let's see if I can go back. That's back, isn't it? There should be another map over here. So, by 1900, which is where I'm going to stop tonight, as I said, this is part one. I hope you've seen just how many amazing discoveries and how many fundamental steps forward in terms of for the science of geology came from here. Came from ordinary people working to make money from the rocks here. What they ended up with by 1900 was an appreciation of just how complicated this landscape was, what the order of layers meant, what fossils were in there and what those fossils were telling us. They were telling us at the sides of that Black Country area where the red rocks are that we know there's been significant bigger earth movements and that we can go deeper down to find the resources and continue to operate the industries of the Black Country. But there's a lot more to be discovered that we haven't answered in this story. For example, when did all this happen? So we might know that this came before this, but at what point did we understand exactly when that happened and when this happened? We know now the temperature of those worlds that delivered some of these rocks. We know the chemistry of the environments they were in. We know how life ebbed and flowed with challenges across the planet. But we didn't at this point. At 1900, we know there's a big story. We've developed a toolkit for teasing out some of the answers. We've invented geologists, thank the Lord. And we've even got a museum in Dudley. But where's it going next? And for that, you're going to have to invite me back. Thanks, everybody.